Okay, so as in the last video, we were discussing about factors that affect vapor pressure. So, factors affecting vapor pressure, right? Before this, we have discussed evaporation, vapor pressure, what is difference in them. What is evaporation? Evaporation is nothing but when you take a container, in that container you take a substance, right? So there you're gonna find molecules. Some molecules would be surface molecules and some molecules would be bulk molecules. What are bulk molecules? Bulk molecules are the molecules which are present below the surface of the container, right? And on the bulk molecules there are so many attractive forces uh, working on those, right? But when we talk about surface molecules have less attractive forces. So because of these less attractive forces, um, they have tendency or they have ability to be escaped from the container. And if these molecules are escaped from the container, this process is what we call the evaporation, which means the escaping of the surface molecule from the container, from the open container, is what we call the evaporation. And then we discuss about vapor pressure as well. Vapor pressure is generated when you take a closed container, right? Again, I'll gonna explain you with the same example. There are two types of molecules, bulk molecules and the surface molecules. See, bulk molecules would not be evaporated, they'll not gonna take place or they're gonna not take part in creating the vapor pressure. But what this all would be done by, it would be done by the surface molecules only. Okay, so as we know that surface molecules have less attractive forces. Because of these less attractive forces, now they won't be scapped, since now we have a closed container, right? So when they will gonna try to get evaporated, but they will not be evaporated, since we have now taken the substance in the closed container. So because of this closed container, these molecules were going to hit the wall of the container, and because of the hitting on the wall of the container, they're going to generate a pressure, and this is what we call the vapor pressure. We have discussed the definition of vapor pressure as well. Vapor pressure is nothing but it is just a pressure above the liquid surface, is what we call the vapor pressure. Or vapor pressure is achieved during the equilibrium between evaporation and condensation, right? How evaporation? When these molecules are changing their state into gaseous, and then these gaseous molecules are hitting on the wall of the container, they are generating a pressure, and because of that pressure, now these gas molecules are again changing their state into liquid. So this is when the gaseous state is changed into the liquid state. This process is what we call the condensation, right? So this is the equilibrium point where evaporation and condensations are achieved. So afterwards we discuss about factors affecting vapor pressure. There I told you that we're going to study only two factors which will be mostly studied in every book. If you take Punjab and if you take any board book, you're going to find more than two. You can find more than two as well, but mostly you will gonna find these two very important points or factors which will gonna affect the vapor pressure. So first point we discuss, vapor pressure has nothing to do with the shape and size of the container, but it is only achieved during the closed container. It is only achieved by using the closed container. Now see what's the meaning of this. If I take this container and if I change the size of this container to this container, right? So now see, their sizes are totally different, right? Their sizes are totally different, their shapes are totally different, but they will gonna have the same vapor pressure if you will have a same substance in it, right? So vapor pressure has nothing to do with the shape and size of the container, but it is only achieved by using the closed container. So you can have a look here, this is closed container as well as this is closed container. So vapor pressure has nothing to do with the size and shape of the container, but it is only achieved by using the closed container. If you're gonna use the open container, the molecules of the water would be escaped from there, and that process would be known as evaporation. But instead of using open container, you are using closed container, then water molecules would not be escaped from there, but they're gonna hit the wall of the container, they'll gonna create a pressure, right? And this is what we call the vapor pressure. So they are only achieved by using the closed containers. Second, we discuss vapor pressure is affected by the nature of the substance. See, it has nothing to do with the shape and size of the container. It is only achieved during the closed container or using a closed container. Secondly, vapor pressure is affected by the nature of the substance, which means whatever size it has, whatever shape it has, whatever size it has, whatever shape it has, vapor pressure has nothing to do with it, right? But if you are going taking here NaCl solution and you are going to take here ethanol solution, so vapor pressure would be affected by the nature of the substance, since we said vapor pressure is dependent on the nature of the substance, and we have two nature of the substances. Either the substances can be volatile substances or they can be non-volatile substances too. Now see, what does mean by volatile substance? The volatile substances which can be evaporated, right? Or which can create vapor pressure. They create vapor pressure, right? And what are non-volatile, which does not create vapor pressure? Simple, right? Create vapor pressure. Now what are example of these? Let's see. The volatile has so many good examples. For example, ethanol. Ethanol can be evaporated very fast. Ethanol or um, glycerol, they have very good ability to be evaporated or to create the vapor pressure. But in the non-volatile we have urea, which will not create the vapor pressure, right? Urea, we have NaCl, urea, NaCl, or you can take more examples as well, right? So volatile substances which do not have, which have ability to create vapor pressure, which have ability to be evaporated. Non-volatile substances which do not have ability to create the vapor pressure or to be evaporated, right? So this was all for today. In today's video we have discussed actually two types of substances, volatile and non-volatile, right? So in the next video we're gonna initially mix volatile with volatile substance, and then we're gonna apply Raoult's law in it, and then we're gonna mix volatile with non-volatile, and then again we're gonna apply the Raoult's law in it. See, we can apply volatile with volatile, we can apply volatile with non-volatile, but we cannot apply non-volatile with non-volatile, which means simply it cannot be evaporated, right? So there is no any importance of mixing non-volatile substance with the non-volatile, but you can actually mix volatile with volatile, since it will create the vapor pressure. You can mix volatile with non-volatile, since it will create the vapor pressure as well, but you cannot mix non-volatile substance with non-volatile, since it will never gonna have any ability to be evaporated or to create the vapor pressure, right? So in the next video we will initially gonna see an introduction to the Raoult's law, then we will mix volatile substance with volatile, then volatile with non-volatile. So this was all for today.